Hey guys, it's Miss Johnson here, and I'm here to bring you our first video in the Algebra 2 series. Today we are talking about Pythagorean theorem notes. We're doing Pythagorean theorem. So go ahead and pull out your notes sheet, and we're going to talk through some things together. So now let's just talk about where the Pythagorean theorem actually comes from. Years ago, a man named Pythagoras found out an amazing fact about triangles. He learned that if a triangle had a right angle, or in other words, a 90-degree angle, and you made a square from each of the three sides, kind of like in the picture you see right there, then the biggest square had exactly the same area as the other two squares' areas put together. This is where we got the Pythagorean theorem, which is a squared plus b squared equals c squared. Now, most of us have worked with the Pythagorean theorem in the past. We're just going to go a little bit further in these notes today. So go ahead and write down the Pythagorean theorem. A squared plus b squared equals c squared. Now keep in mind when we're watching these videos, remember that you can pause it, you can stop it and come back to it, you can rewind, you can watch it more than once, whatever you need to do. Let's move on to number 1. It says find the missing side of the triangle using the Pythagorean theorem. So I have a side of 6, a side of 15, and I'm finding the hypotenuse. Remember that hypotenuse is the longest side, or in other words, longest side. So if I put this into the Pythagorean theorem, because I know it has a right angle because of that, then it looks like this. I have 6 squared plus 15 squared equals x squared. 6 squared plus 15 squared equals x squared. If I square both of those, that means I get 36 plus 225 equals x squared, which is 261 equaling x squared. Now, I want to take the square root at this point. If I go back up to the top and you take a look at that note that's up there, it says leave your answers in simplified radical form. Simplified radical form. That means we're going to pull out the perfect squares. We are not going to be writing these as decimals, and that is not how you will see them on tests and quizzes. You're going to be writing them as simplified radicals. So what that does for us is when I take the square root, I need to look for perfect squares that come out of 261. Well, I found that 261 is the same thing as 9 times 29. So that means if I put that back under my radical, I have the square root of 9 times 29, and I can take the square root of 9 out. So it becomes 3 square root 29. There's no perfect squares in 29, so I can't break down anything else. So that is my value of x. Again, simplified radical, not the decimal version. So it's a little bit different than what you've probably done in the past. Let's take a look at number 2. In number 2, again, I'm missing the hypotenuse. I have one side of a triangle being 7, one side of a triangle being 17, and I'm missing the hypotenuse. So again, I can plug that into the Pythagorean theorem. 7 squared plus 17 squared equals x squared. That's 49 plus 289 equaling x squared, or 338 equaling x squared. So again, I'm going to simplify the radical there. I'm going to figure out what perfect squares I can take out of 338. Well, when I break apart 338, I just started with 2. 338 is the same thing as 169 times 2. Now I recognize that 169 is a perfect square. 169 is 13 squared. So when I take the square root of these, because I know that that's how I'm going to get my x by itself, that's the same thing as the square root of 169 times 2. And then the square root of 169 can come out and be 13. So I have 13 times the square root of 2 equaling x, and there's my simplified radical. All right, so now throughout these videos, I'm going to have you pausing them at certain points to complete some questions on your own. So this will be one of those times. I want you to pause the video and see if you can answer number 3. And let's move on to number 4. It says Damon is locked out of the house with only an open window on the second floor 12 feet above the ground. He needs to borrow a ladder from his neighbor. He must place the ladder 5 feet from his house to avoid some shrubs. What length of the ladder does Damon need? So how long does the ladder need to be? If I take a look at this picture that's drawn on the house, I can assume that the ground and the house form a right angle because they're going to be perpendicular to each other. I know that he needs the ladder to be 5 feet out, and I know that the window is 12 feet up. So what I'm missing is the hypotenuse. So I'm going to plug that into the Pythagorean theorem. I have 5 squared plus 12 squared equaling x squared. 5 squared is 25. 12 squared is 144. And then putting those together, I get 169 equaling x squared. Take the square root of both. 169 happens to be a perfect square, so I don't need to get a simplified radical here. I get 13 equals x, so I'm looking for a 13-foot ladder. That's the height of the ladder that he needs to get into that window. Okay. Now let's talk about some common Pythagorean triples at the bottom. You can see that 3, 4, 5, 5, 12, 13, and 7, 24, 25 are common Pythagorean triples. So what we know about these Pythagorean triples is that any multiple of these will also be Pythagorean triples. For example, I can take these and multiply them by 2 and I get 6, 8, 10. That will also be Pythagorean triples, meaning those 3 side lengths make a right triangle. Same thing if I keep going. Multiply them by 10, 30, 40, 50. Any multiple of 3, 4, and 5 is going to give you a Pythagorean triple. 5, 12, 13, that's the one we just worked with in number 4. Same thing here. I could double these, 10, 24, 26. And I know that that's going to be a Pythagorean triple. Same thing if I multiply them by 10 or any other number. 5, 50, 120, and 130 will also be a Pythagorean triple. And I can do the same thing with 7, 24, 25. So most of the time when you're seeing Pythagorean triples, it's going to be some multiple of these 3. These are the basic 3 that you'll see quite often. Let's flip over to the back and take a look at the next couple practice examples. In number 5, it says find the value of x. So what I notice is that, first of all, I see my right angle. There it is. That means this right here is going to be a right triangle. So I have to take a look at the sides that I have. I have the hypotenuse, which is C. I have one of the sides, I can call it A, it doesn't matter if it's A or B, and I'm missing the other side. So I'm going to plug that into the Pythagorean theorem. I'm going to have 10 squared plus x squared, because that's my other side length, equaling C, which is 14 squared. And then I can go through and solve that for x. 10 squared is 100. Plus x squared, 14 squared is 196. And then if I subtract 100, I get x squared equals 96. Taking the square root, I can certainly pull out a perfect square there. I know that this is going to split into, and again, I'm just using prime factorization here, 96 splits into 16 and 6. So when you're breaking down these radicals, you just need to find out what the prime factorization is or figure out what numbers go into there. And I found 16 because it's a perfect square, and so I know I can take it out. So if I split that apart, I have x equaling the square root of 16 times 6. And the square root of 16 can come out front, so I have x equals 4 square root 6. Okay. Let's try one more together. I have, in the next triangle, in number 6, I have x squared, or I have x on one side, I have the square root of 2 on another side, and I have x plus 1 for a third side. And I'm trying to find the value of x. Let's get rid of that. Here, we're going to take a look at number 6. So, again, I'm just going to drop these into the Pythagorean theorem. Here are my 2 legs, and that is my C, my hypotenuse. So I have x squared plus the square root of 2 squared equals x plus 1 squared. Now let's talk about what happens when we take care of all that stuff, all that simplifying. X squared we can't do anything with, so I just leave it as x squared. The square root of 2 square, we all know that when we square root something and then square it, those two cancel each other out. It's kind of like addition and subtraction. They're opposite operations. So if I take the square root of something and then square it, I'm left with just what's underneath, which is 2. Now, don't forget that this is a binomial, so I actually have to do x plus 1 times x plus 1. And when I FOIL all of those, I'm going to end up with x squared plus 2x plus 1. Okay, so squaring my binomial, that's what that looks like. That's just a common FOIL question. Now I need to solve for x. Well, one thing that I notice that's going to happen that'll help me a lot is when I move my x squareds over together, X squared minus x squared goes away. Well, it also goes away over here. So that helps me out a lot. I'm done with the x squareds. So now I'm left with 2 equals 2x plus 1. So then this is just a basic two-step equation. Subtract the 1, that's 1 equals 2x, and divide by 2. So I end up with x equals 1/2. No radicals to simplify, no other squares to deal with. So there's my value of x. All right, I want you to go ahead and pause the video at this point and try and work on number 7. See if you can find the value of x in that shape. And that's going to conclude our video portion for today. Thanks for listening, and I will see you all later.